Hello, my name is Jack Barrich, and this is Ocean Solutions, a podcast produced by Altasea at the Port of Los Angeles. Altasea is developing the most innovative ocean research campus in the world, a place where scientists, educators, and business people can work together on solving some of mankind's most pressing challenges, including climate change, energy supply, and global food security. On today's show is Rusty Jehangir, the founder and CEO of Blue Robotics, an underwater drone company that is one of Altasea's partners in their Blue Tech cluster. By creating exponentially more affordable marine products, Blue Robotics has opened the door for many new academic researchers, schools, and citizen scientists to explore the ocean. This has the benefit of dramatically increasing the scale of ocean research and the many solutions that can come from that. This is so important. I hope you listen and enjoy the show. Hey, Rusty, really great to have you on the show.
Glad to be here, Jack.
You have a company, Blue Robotics, that makes underwater drones or parts for underwater drones that are far more affordable than previous companies or previous folks made available. In your opinion, how can the affordability of the drones and the drone products make science more democratic and advance this scientific understanding of the ocean? Like, what is it that you provide that can lead to ocean solutions?
Yeah, so we make a whole line of components to enable marine robotics. They're all like, we shoot for making things 10 times less expensive than what is on the market already. And what that does is it opens up all of the possibilities to scientists and entrepreneurs and explorers, because all of a sudden something that was previously cost restricted is possible. You know, when something's 10 times cheaper, it really changes the game. So say you're a scientist and you want to film some species of marine animal that's never been filmed. You can now build, like, you can take these components, you could build a camera system that's designed to film that specific creature, very customized, built for that application. And that's something there's 1,000, probably 1 million different applications like that, that are just open to your imagination.
So, like, and I'm just kind of making this up on the fly, but like, as an example, in the past, maybe a ocean research department of a university could maybe afford one drone. They'd all have to go out as a team. And now if you have several, you can even have individual students or small teams of students that can go out and do research, because that same university department now can afford 10 drones or 15 drones, whereas before they could only afford one. Does that create sort of more opportunities for different types of research that they can do and find things that maybe they have otherwise wouldn't have been able to?
Yeah, absolutely. So our flagship product is called the Blue ROV2. It's a remotely operated underwater vehicle, and something comparable to what we've got would be like close to $100,000. Ours is closer to $4,000. And so all of a sudden that's $100,000 for something is, even a high school, even a college is not going to purchase that unless they really need it. So by bringing that price point way down, we have like high school classrooms that are building these ROVs themselves, learning the engineering steps that are involved, learning the physics behind how it works, and then taking it out and actually doing real science with it in their local ponds or lakes or rivers, wherever that may be.
Yeah, it's interesting because when we're over here at Altasea, we talk about this a lot, that the ocean covers over 70% of our planet, and there are estimates that only 10%, over 90% have not been explored. 90% of the ocean hasn't been explored. With so much of this ocean that hasn't been explored, do you think citizen science might be the way a lot of that ocean gets covered? Because, if you have the institutions, even the institutions trying to cover this massive space can't cover it all. But if you have hundreds, thousands, at some point maybe even millions of people doing their own sort of citizen research, there's something that can come out of that we don't even know, right? There's stuff down there we have no idea what's at the bottom of some of those spots, wherever it is in the world.
Absolutely. So there's obviously a lot of the ocean that's out of reach for a normal person. You talk about the Marianas Trench, or even the average ocean depth is 4,000 meters, which is very difficult to explore. But so much of the ocean is within 100 or a couple hundred meters near the shoreline, and has very interesting, unexplored areas. Even if we've mapped out some area once, that doesn't mean it looks exactly the same today. That doesn't mean there's not something there that we haven't seen.
Right.
So I think those numbers on how much of the ocean has been explored are open to a lot of improvement.
Yeah, yeah, and the ability of getting these products into as many hands as possible means it's just a natural thing. Exponentially, you're going to have more people out there, more things are going to be found. And,
Yeah.
and it's always like, well, I think the analogy is almost like you and your company and the sort of startup culture that exists in our country, Silicon Valley being the most famous place for that, is you get 3-4 guys in a garage, they figure out how a product might be improved or a whole new product created, and next thing you know, an entire industry comes out of those 3-4 guys that sat in a garage, and that garage in the future could be the ocean with the products that you're creating.
Absolutely. So since we're just building those parts, we have a lot of people that are doing really interesting applications with that. And there's a lot of I wouldn't call them spin-off companies, but there's a lot of companies whose mission has been enabled by just having access to parts. I can give you a couple cool examples.
Yeah.
There's a company called RSE that is building drones specifically to address the problem of invasive lionfish in the Caribbean. So there's these lionfish. They're originally sold for aquariums. People dumped them in the water. Now there's thousands of them. They're eating everything. People are hunting them as scuba divers, but scuba divers can only go down to 30 or 40 meters practically.
Right.
And these lionfish are living all the way down to 1,000 meters. So they've taken a lot of our components and they've built a lionfish hunting robot that can capture these lionfish at greater depths, uses these electrical plates to stun them and then suck them into a vacuum cleaner basically, and bag up as many lionfish as they can fit. They bring them back to the surface and they are selling them to restaurants as seafood. And they're trying to create a whole industry around this so that they can monetize an invasive species and solve a problem while creating a business model out of it.
Right.
There's a very similar project in Australia to address the problem of Queen of Thorns starfish. The University of Queensland, they've built a completely autonomous underwater drone using a lot of our components that uses stereo cameras to navigate around the reef very accurately, and it finds these Queen of Thorns starfish and then basically has a robot arm with a needle on it and goes down and gives them a lethal injection.
Right. And what do they do with these starfish when they bring them up?
Those they just actually kill in place because there's no monetary value to them. So they give them a lethal injection and get rid of them.
Why would they want to get rid of them? I don't know.
They just eat the other corals in the area and they destroy the reef.
Starfish?
Yep.
Ah, interesting. And that by eliminating the starfish, they save the coral reef.
Yep, exactly.
Oh, interesting. I've never heard of that. I've seen your company. So all of this is now like at a level, you're talking about companies and universities. But I think one of the brilliant things about your company is what it can do for kids who are elementary school, middle school, high school level. And, I've seen your kids engage in education workshops for kids at Alta Sea. My own kids got to operate a drone at one of the open houses, and I'm telling you, I couldn't get my kids to go home that day. And usually they're like, hey, that was fun, Dad, can we go now? And on this particular day, they had that little Sony PlayStation joystick, and they were operating the drone, and they were just like in heaven. They didn't want to leave. So talk about that. Talk about some of the things that you guys do to get the next generation excited about engineering and exploring the ocean.
So I think helping out with these educational programs is probably the most satisfying part of what we do, and it's one of the most meaningful parts of what we do to our entire team. There are a lot of high school ROV competitions. There's one for the youngest kids called Sea Perch. There's one for mostly high school kids called Mate. In college, there's the AUVSI RoboSub competition, and we sponsor all the organizations that run these competitions. And we go to the competitions. We support the kids. We always answer their emails and technical support. Try to give them guidance, and you really see the passion that is excited in these kids by the fact that they can build robots. They can build robots that can solve environmental, ecological problems in the world, and that all of this is within their reach and something that is possible to them. And so helping educate them on that and providing them with some products and components that fit within a school's budget is really fantastic.
Yeah, that is awesome. So you guys are around a lot of young people. Do they give you hope for the future of solving these challenges that we have in the ocean? Because I think a lot of times people get caught up with the problems, and there's obviously massive problems, plastic being maybe the one that jumps out the most right now. But I always feel like if you just bet on human intelligence, we tend to we're really good at messing it up, but we're also really good at fixing it because we're smart. And when you're around kids, do they give you hope? What do you think of like our future when you do engage with these kids?
Absolutely. I can tell you, I'm not that old, but when I meet these young kids who are involved in STEM education, robotics, it just blows my mind. How quickly they're learning and what they have access to today. And if they're if they're building these robots when they're in middle school or high school, I'm very optimistic for what they'll be doing in their career paths and what they'll be doing to help the world. I think they'll have a great interest in that. They've grown up in a time where that's been on the top of their minds their entire lives, and I think they will do a good job of helping to solve those problems.
I agree. I think there's an interesting time because on one hand we're getting a lot more awareness of the challenges that do exist and the problems that do need to be solved. And on the other hand, we're also expanding our technology so rapidly, and kids are so comfortable with it. So they've got the mindset of these problems that need to be fixed, and now they're going to have the tool set to be able to go out and fix them.
Absolutely, it's really exciting.
Yeah. Hey, Rusty, thank you so much. This is fun. Really appreciate having you here, and we'll look forward to seeing you again next time.
Thanks for having me. It's been a pleasure.
Yep. Thank you. Thank you for listening to Ocean Solutions, produced by AltaSea at the Port of Los Angeles. To learn more about AltaSea, please visit altasea.org.